Hey Kelly, welcome to lesson 95. Okay, this lesson is called multiplicative. I don't know how to say that word. The multiplying property of inequalities. Inequalities are these things right here: greater than, less than, greater than or equal to, less than or equal to. Okay? And you're going to be graphing them on the number line. I am sorry that I don't know exactly what your base is in all this because I haven't taught the rest of the book with you, but I can go over the basics today to make sure that you understand it, and then if you still don't understand it or you're like, there's a piece missing, Mancheska, just let me know and I can help you out with it, okay? So what you're doing is you're taking this inequality right here, solving it for x, where x is alone, okay? And so you can get an expression that x is greater than or equal to or less than or equal to whatever is on the other side, and then you represent it on this number line. You have to pay attention though to your domain. Your domain is what are the possible x answers. So for example, in this one, it's real numbers. So that means anything that's a real number, which basically right now for where you've gotten into algebra are any numbers that you know. It could be a fraction, it could be a decimal, it could be a negative number, it could be a positive number, it doesn't matter. Non-real numbers are imaginary numbers, they call it, and we haven't gotten into that. You don't get into that until advanced math, so you don't have to worry about that right now. So when it says real numbers, you're like, woohoo, happy days, because you basically can just ignore this thing right here. Oh, because you don't have to change anything when it's real numbers. Okay, when it's integers, it's a little bit different, but it's easy and I can show it to you. So look right here, we're going to solve for x. The only thing that's wrong with this x right now is that it has a negative on it, okay? But here's the rule that you have to remember and you have to know. So look what we're going to do. We're going to divide by a negative 1, right? Divide by a negative 1. So what do you have? You have x something greater than or equal to or whatever to negative 2. Here's the one big rule about solving for x when there's an inequality symbol here and not an equal sign. That when you divide by a negative number, it's only then, when you divide by a negative number, you literally have to flip the sign, okay? So now it's not greater than and equal to, it's less than and equal to, okay? You don't do anything else, you just flip it, okay? So when it was, the big boca was on this side, now it's gonna be on this side, okay? That's all you have to do. So divide by negative 1 over here and flip your inequality sign. Which means now that this is how you read the sentence. X is less than or equal to negative 2, okay? So here we go. I'm just gonna put a negative 2 right there and I'm gonna represent this by coloring in the number line. X is any real number less than or equal to negative 2. Well, Kelly, when you see that it's equal to, it can be equal to, you're gonna color in the circle. If you leave it open like this, it means it cannot include negative 2. Okay, but it can include negative 2, so you color in the circle. Now, where are your answers going to be? Are you going to be on this side of the negative 2 or this side? Well, it's less than. So you color this whole thing and you color this because it says any number less than negative 2 is a possible solution for x. That's what you're saying. X can be anything less than or equal to 2. So you represent it by coloring this side because this side's less and this side's more. Okay? Let's look at example 2. 4 minus x is less than or equal to 6. Okay? Don't worry about this yet, but we do need to look at that because that's integers. It's not real numbers. Okay, so let's solve for x. Here we go. We're going to do negative x is less than or equal to, we're going to move over to 4, 2. We do not flip it just because we're minusing 4. We only flip it when we're dividing by a negative, which we're going to do right here again. So divide over here by negative 1, divide over here by negative 1, and we're going to flip the sign. So x is greater than or equal to negative 2, okay? So again, we're going to put our negative 2 right here. Okay, now be careful. It is including this negative 2. We do know that. Okay, it is including the negative 2 because it has the equal sign right here, okay? But this says integers. Okay, Kelly, I'm going to tell you what integers are. Integers are whole numbers, negative and positive, okay? No fractions, no decimal numbers, okay? Which means what are your integers? -2, -1, 0, 1, 2, but it can't be like negative 1.5, negative 0.5, negative 3/4. It can't be any decimals and it can't be any fractions. Okay, so you can't just simply color, okay? It says that x is greater than or equal to negative 2. You can only color in your integers because that's what your possible domain is. So you literally have to go and write a few integers on your number line and color them like this, because it includes each one of these, but it cannot include things in between, because things in between are your fractions and your decimals. So you cannot do that. You have to color it like that. So when you see integers, you have to do a little bit more brain work on it to say, okay, what are my integers? They're my whole numbers that are negative or positive, but never a fraction. Okay? We have example 3 to do, which is a real one, woohoo. And then you've got 3 good examples in your practice that we're going to do, 2 of them being integers and 1 of them being real, so you'll get some good experience there. So let's go ahead and do example 3, then we'll jump into our practice. Okay, cool thing about number 3 is that the domain is real, so we're going to cross it out because we don't care, because it can be anything on this thing. Now we're going to solve for x, right, Kelly? So we move the 4 over here. That's negative 3x. We haven't changed our sign yet. This is going to be 9, but now when we divide by negative 3, we're dividing by a negative number, so we need to flip this sign. Okay, so it's going to be x is greater than or equal to negative 3. We know it because it means x is greater than, because the bigger side of the boca is on the x side. So now we go negative 3, right? And we're going to color this in because it is including it, because that's why it has this right here. And we're going to color to this side because it's greater than, Kelly. And that's all you do, okay? So go ahead and try your practice knowing what I just taught you. And we'll come back and check it. I put the answer for letter A up there, but I'm going to show you letter B and letter C. I'm so mad at them on letter B because they didn't even teach you what to do when there's a line through it. Sorry about that, because I did not see that. They don't give you any examples of that in the entire lesson or in the reading for the lesson. Pero ni modo, aquí estamos. Okay, so here we go. This one right here was easy, right? Because it was a real domain of real, so I didn't even write it down because we were going to ignore it anyway. We divide by negative 1 over here to get a negative 5, but we had to flip the sign. So now it's going to be negative 5, include the 5 because there's the equal sign. And we color to the left. Now this one, okay, when it has a line through it like that, that means that it's not less than or equal to. If it's not less than or equal to, Kelly, we need to flip it and take off the equal to, because that means it's completely contrario. Completely contrario. So, if it said it's less than or equal to, now it's just greater than. Now it's just greater than, okay? If it had a line through the greater than, then it would be now less than or equal to, because that's the complete opposite, okay? It wasn't equal to before, now it is, and you flip the sign, okay? It is integers, okay, so just keep that in mind. So let's go ahead and solve for it. We're going to move the negative 2 over here, right, because we changed the sign. So you have negative x is greater than negative 1. But now we have to divide by negative 1, right? So we divide by negative 1, so now we have x is, flip the sign again, because you have that negative 1 there, and it's going to be x is less than 1, okay? When you flip the sign, you don't put the equal sign back on there, because it's just flipping the sign this time, okay? So let me erase this part, let me show you what we're going to do. Because it's integers, and it's not including the 1. It's not equal to the 1. So when I put the 1 here, Kelly, when I put the 1 here, I'm going to have to go less than. So let's go 0, negative 1, negative 2. Those are my integers less than 1. But guess where I'm going to start, Kelly? I'm going to start right here. It includes 0. It includes negative 1. And it includes 2, okay? Why? This is a weird one, so listen to my explanation. It is only integers less than 1. And because there isn't an equal sign here, it is not including the 1 at all. So yes, you can put the 1 on your number line, but no circle goes there because you cannot include the 1. You have to start at the first integer less than 1, which is 0, okay? Then you're going to ask me, Jessica, then why do we color in the circles if there's no equal sign here? We color in the circles here because it does include the 0, it does include the negative 1, and it does include the negative 2, okay? If you wanted to put a circle here that's not circled in, because it says it's not including the 1, that's fine. I'm not going to take off for that. If that makes you feel better, because then you have 1 empty circle here that is not equal to. And that's perfectly fine, okay? But logically speaking, you're going to start with the integer less than 1, okay? Let's look at letter C. Another kind of weird one, okay? So we have, move over a -5 here, that's going to be -4. So you have -3x is greater than 4, okay? But we're going to flip the sign because we're going to have to divide by a -3. So let's move it over here. We have x is now less than 4/3. Okay? X is less than 4/3. Well, here's the thing, Kelly. 4/3 isn't even an integer, and that's what we're dealing with right here. Okay, so here we go. This is, first of all, going to be 1 1/3, okay? Because just to help us know what that is. So when I put that on the number line, 1 1/3, it's x is less than that, and it's only integers. Well, what's the first integer less than 1 1/3? The first integer is 1, okay? So that's where I'm going to start. 1, 0, -1. So I'm going to go circle this in, circle this in, circle this in. Because it's only integers less than 1 1/3 that are included in this. Okay? Let me see. The complicated ones for your homework today are going to be they only give you 2 on your homework today. Number 5 and number 20. Okay, number 5 and number 20. But really only number 5 is actually, no, number 20. Okay, so let me know on number 5 and number 20 if you need any help, and I'd be glad to help you. Especially be careful on number 20. Check that answer really well when I send you the answers, because there's a little bit of details that you don't want to miss. Okay, thank you. Have a great day.